Hello kiddos, welcome back. This chapter is going to be over midsegments and points of concurrency. And so today we're going to start note 6.1, midsegments and coordinate proofs. Our objective will be to use the midsegments of triangles in the coordinate plane and to use the triangle midsegment theorem to find distance. And this can be found on pages 298 through 302 in your textbook. You were supposed to do a midsegment exploration prior to watching these notes. So if we want to talk about how the midsegments of a triangle are related, the midsegments of a triangle connect the midpoints of each side. So through your exploration, you should have realized that the midsegment connects the midpoints of each side. Every triangle has 3 sides, therefore every triangle also has 3 midsegments. The midsegments together form the mid-triangle, and the midsegment is going to be parallel to the third side. All right, so hopefully out of that information, you got those answers, and we can go on with the midsegment theorem. So when I read the midsegment theorem over here, it says, if a segment joins the midpoints of 2 sides of a triangle. So if I look at this picture, I have D and E, and they're both midpoints. And we see that by this mark here and this mark here, as well as by these marks over here. It says, then the segment is parallel to the third side, and it is half as long. So it says that if you connect the midpoints, then that's going to make those 2 segments parallel. So DE is going to be parallel to segment AB. And it also says it's half as long. So DE is going to be half the length of AB. The other thing you could do is say it's going to take 2 midsegments or 2 DEs to equal 1 AB. So it just depends on kind of how your brain works as far as that goes. They both mean the same thing. All right, so let's tackle example 1. So it says use triangle GHJ where D, E, and F are midpoints. So if D, E, and F are midpoints, then we have ourselves a bunch of congruent sides. It also says that DE is 4x plus 5. And that this whole segment GJ down here is 3x plus 25. So by using the midsegment theorem says if we take half the long side, so half of 3x plus 25, that is going to equal the short side, 4x plus 5. So for me, in a fraction prevention move, I'm going to multiply each side by 2 because here these fractions will cancel out. And over here, I can distribute this 2 to each of these parts. And by doing that, I eliminate any fractions in this problem. So it makes the algebra just a little bit easier. So I can just continue to do my algebra. I'm going to go ahead and move that 10 to the other side. Whoops. And then x is going to equal 3. So if you go back and you look at your problem statement, it says what is DE? Well, DE is going to be 4 times x, which we found is 3, plus 5, or 17 units long. All right, so now if I look at HJ, so if I come over here to my picture, HJ is this segment right here. And DF is this segment right here. I'll be honest with you, I think of this in a different perspective. I think that it's going to take 2 DFs. So for me, it's going to take 2 DFs to equal HJ. So 2 midsegments equals the length of the parallel third side. So I'm going to take 2 times DF, which is 2x plus 11, and that's going to equal 8x minus 2. And we are going to distribute the 2. And I'm going to add 2 to these sides and subtract 4x from these sides. So if you need to hit pause and do your algebra, you can go ahead and hit pause and do your algebra. In the end, I get that x equals 6, so they want to know that what is hj. So hj is 8 times the value of x, which I found to be 6 minus 2. And so we get a grand total of 46. All right, lots of algebra. You just got to be able to get the problem set up. Okay, so here we don't have a triangle, so we are definitely going to have to draw a triangle. So it says we have triangle QRS. So I'm going to come over here and just arbitrarily, I'm going to draw a QRS. And then it says T, U, B are midpoints respectively. So since I started with Q, I'm going to have a midpoint T right here. I'm going to have a midpoint R right here. And I'm going to have a midpoint S right here. So the length of a midsegment is half the length of the third side. So if I go ahead and come in here and I connect all of these points, it says TU, I labeled my points wrong, timeout, this point here should be U, this point here should be B. Apologize for that mislabeling. Okay, so let's tackle the problem again. So it says that TU, so if I look at this side right here, TU is going to be half the length, oops, can't write in yellow, TU is going to be half the length of side QS, but TU is also going to be equal to QB, and it's going to be equal to BS, because all of these triangles are basically congruent. So we have, basically you're going to have a set of 4 congruent triangles in here. So now if I look at UB is this segment right here. So UB is going to be half of the parallel third side. So UB is going to be half of side QR. But half of QR would be QT, or it would be TR. So this side right here is going to be congruent to this piece here, as well as this piece here. And last but not least, we have side TB. So if I look at side TB, I'm looking at this side here, which is parallel to this third side here. It also means that if you use the midpoint, we have congruent segments here, we have congruent segments here, and we have congruent segments here. So TB is going to be equal to half of SR, and that means that SU is going to be equal to that, and that UR is also going to be equal to that. Okay, perfect. Okay, guidelines for coordinate proofs. 1. Use the origin as the vertex or the center point anytime you can. It will make your proofs a little bit easier. Anytime you can place at least one side of the polygon on an axis, go ahead and do so. Make sure you keep the figure in the first quadrant, if at all possible, and use coordinates that make computation as simple as possible. So the more we can place things on the axes, the easier this will be. Okay, so we're going to sketch triangle ABC and find the length and slope of each side. Then find the coordinates of each midpoint. If triangle A is triangle ABC a right triangle, or is it isosceles? Please explain. Okay, and you can assume all variables are positive and that m does not equal n. All right, so if we think about this figure, we have the point 0 in for point A. We have the point m in for point B, so I'm going to go over m, and I'm going to go up in. So I have this point m in, and then I'm going to go over m, and I'm going to go up 0, and then I'm going to connect these 3 points. All right, so now it asks us to find the length, the slope, and the midpoint of each side. So here's the difference. You're just going to be using letters, which I know you guys don't love, but I'm going to do one set of sides, and then I want you guys to do the other ones on your own. So I will go ahead and do side Let's see, M0, I forgot to label this. This is point C, this is point B. I will do side AC, and I will let you guys do side AB and BC on your own. Okay, so if I want the length of side AC, I have the point 0N, and I have the point M0. So the distance formula says the square root of x minus x plus y minus y squared. So this is going to become m squared plus n squared, and you're just going to have to leave it like that. There's nothing else you can do. Leave your answer and move on. If I want the slope of side AC, I'm going to take y minus y. So I'm going to take n minus 0 over x minus x, 0 minus m, which is going to give me n over negative m. And it should make sense that my slope is negative because my line goes down and to the right. And then the last thing they want is they want the midpoint. So if you think about how we found the midpoint, we averaged our x coordinates and averaged our y coordinates. So if I take the two x's and I add them together and I divide by 2, and then I take my two y coordinates and add them together and divide by 2, I get m over 2 and n over 2. All right, so at this point, I want you to finish out this last problem by finding AB and BC and finding the length, slope, and midpoint of each one of those. Have a great day, and I will see you in class tomorrow. Bye-bye.